SolidWorks modeling of a horizontal axis wind turbine DFT 170 Engineering Graphics Spring Semester 2022. This presentation is created by Michaela Yvonne Dacanay and Christian Cruz.
For the design reference of the wind turbine, we started off with a sketch. Then we used a photo of the Bangui windmills to get the general shape of each part. In terms of measurement, we used a 1:4 ratio of the actual turbine measurement to model the 5 main parts of the wind turbine.
For the first part, we decided to model the gravity-based foundation because it has more details that would help us show the skills we acquired from the course. To model the foundation, we used three SolidWorks features: the extruded cut, the extruded boss base, and the revolved boss base.
The second part of the turbine is divided into 2 parts, the upper and the lower mast. We decided to model it as 2 parts to get the shape we wanted. To model this part, we used 3 SolidWorks features: revolved boss base, extruded boss base, and extruded cut.
The third part would be the blade hub. It is bullet-shaped and it holds the 3 blades of the turbine. To model these, we again use 3 SolidWorks features: the revolved boss base, the extruded cut, and the circular pattern to cut the blade slots.
The fourth part of the wind turbine would be the nacelle. This part houses the gears of the turbine. We use 6 features to model this part: loft boss base, mirror, shell, revolve cut, extruded boss base, and hole wizard.
The fifth and last main part of the wind turbine would be the blades. To achieve the shape of the blade, we have to use reference geometry and sketch on 7 separate planes and connect each sketch using the lofted boss base feature of SolidWorks.
After modeling the 5 main parts of the wind turbine, we put all the parts together using assembly. Using the mate command, we were able to attach each part to one another. There are also minor parts needed to assemble the wind turbine. These parts include gears, bolts, and a retaining ring.
This drawing document shows the orthogonal views of the wind turbine: the front, top, right side, and isometric views of the model. It also has information like the intended material of the model. And according to our research, the most common material used for wind turbines are steel. On the left, we have the pressure simulation, which shows that when 6,700 newtons of pressure is introduced, the mass would collapse. On the right, we have the air pressure flow simulation, which shows that the blade can handle about 65,000 newtons of airflow pressure. The animation of the wind turbine is pretty straightforward. It showcases the rotation of the blades that is attached to the blade hub. Also, if the animation works, it means that each part was modeled correctly and assembled properly. After finishing the project, we learned that working with a model with more rounded edges compared to flat surfaces can be very difficult, especially in simulation. Given the chance, we would opt for a wind turbine model that has more flat surfaces instead. On this slide, we have the references that we utilized on the project, both for the presentation and the creation of the model of the wind turbine. Thank you for watching our presentation. Have a great day.